In this question, we want to find the sum 1/7 plus 3/7 plus 3 squared over 7 plus, and the last term is 3 to the n minus 1 over 7. We want to add all of them together. N, here can be, let's say, 5, 10, 100, 10,000. So any number. So then we need a general formula. What is that? Now, this is a geometric sequence. You see, if 1/7 is the current term, and the following term will be 3/7, 3/7 divided by 1/7. Flip 1/7 to 7/1. Cancel 7. We have a common ratio is 3. The initial term is 1/7. 1 is 3 to the 0. The reason I want to write in this way is that if here is one index A1, then here the exponent is 1 less than the index. For the second term A2, if here sub-index is 2, the exponent is 1 less. 3 is 3 to the first power. For A3, the third term, 1, 2, 3, the third term, the exponent here is 2. For the fourth term, the exponent here is 3. So for the nth term, the exponent here is n minus 1. This tells us that how many terms is not n minus 1 terms, is what? N terms. You see, 1, 2, 3, 4 until n. So it's n terms. Now, we know the common ratio, we know there are n terms, and we know the first term is 1/7. Then we may denote the upstairs by the expression here. We derive the general formula first. Upstairs can be written in this way. You see, here is n minus 1, here is r to the n minus 1. I is 3, A1 is 1/7. You see the pattern here. A1 is 1/7 plus A2 is A1 times R. Okay, because again, A1 is 1/7 times R. Here it's 3. You have 1/7 times 3, you get second one. So that's the general formula, and that's the special case. Now, here we need to derive the general formula. So both sides multiplied by R. So upstairs, that's the equation. Left-hand side multiplied by R, we got this. Right-hand side S multiplied by R, we get RS. This term A1 times R to the n minus 1 multiplied by R, we have A1 to the A1 times R to the n. And here, A1 times R is A1 R. A1 times R, you then multiplied by R, so it's A1 R squared. So this term after multiplied by R goes here. This term after multiplied by R goes here. And of course, A1 R squared multiplied by R goes here. Now we use the first equation, subtract the second equation, we'll see what we get. So I put the black negative sign everywhere, means upstairs subtract downstairs. So I wrote 1 star minus 2 stars. Then you can see those two terms are cancelled. This A1R squared, A1R squared are cancelled. A1R cubed, A1R cubed are cancelled. First, then A1 cannot be cancelled. So you put right here A1, subtract. This term cannot be cancelled. A1 R to the nth. But this one, A1 R to the n minus 1, A1 R to the n minus 1. Those two will be cancelled. So left-hand side, we have a first term A1 left, and the last term A1 R to the nth power left. Of course, here is subtraction. All the terms in the middle are cancelled, except first one on the top and the last one for the second time. Okay, and here is S. S is 1S. 1 times S is S. Then we have 1S minus RS. Now I want to pull S out, so that will be 1 minus R for this one. Left-hand side, I pull A1 out. I write it on the right-hand side. Left-hand side here, I pull A1 out here, and I write on the right-hand side, and then 1 minus R to the m. Okay, so both sides divided by 1 minus R. Then you have S stands alone, which is A1 times 1 minus R to the nth divided by 1 minus R. That's the general formula for all geometric sequence. Okay, and then we plug in our formula, plug in our concrete number right here. We know A1 is 1/7 here, and R we know is 3. So we have a 1 minus 3 to the nth power divided by 1 minus 3. 1 minus 3 is on denominator, which is -2 times 7. You have a -14. So -1/14, and the numerator is 1 minus 3 to the nth power. This will be our final answer. Okay? I'll see you next time.